Hello and a very good day to everyone. My name is Nordamia Imanina binti Nasraf with the matrix number DE190034, and I will be introducing my teammates. First up is Nur Aida Shahira binti Zakaria with the matrix number DE190020 and Hamirat Shanalaki Ramu with the matrix number DE190055. So now I will pass to the next presenter.
Assalamualaikum, my name is Naida Shera binti Zakaria. I want to explain about the introduction. Mary is a simple design that consists of memory, storage, program, and data. CPU that consists of an ALU and many registers. ESO or the necessary functional component to function as a true computer. Then we assume a standard bus system for the data flow in memory because there are 7 registers and value per accumulator or AC is a device that can store input data. It is a memory register that stores data for a CPU to process. IR in register, out register, MAR, MBR, and PC. The MAR provides input to the memory address line, allowing the CPU to determine where memory to read or write as well as a distinct channel from MBR to the AC. MBR, there is a specific channel on the MBR that can be used for arithmetic operation. Data can also go back and forth for the AC to the AMU. For the PC, the address or the net instruction being executed inside the program is stored in the program counter. The instruction register for the net to be for instruction. The input register store data from the input device. The output register data from the output device. For the sake of the load, the first level of action we can get the following language. This language is assembly language. It instruction as a memory representation that corresponds to it. It doesn't architecture as its own set of assembly language. Okay, for the net introduction, the register are linked together and a common data bus connect them to the memory. Its instrument on the bus as a unit identify that is set on the device no whatever it is necessary to perform a transaction. There are also distinct connections between both the accumulator and the program memory register as well as the ALU and the accumulator as well as the storage buffer register. The operating system architecture of a computer determines the format of all is common as well as the primitive function is performed. Its ISA is a hardware software interface that connects desktop hardware and software. ISA can have hundreds or different instructions for data analysis and program execution. Okay, for the next slide.
Hello and very good day to our lecturer. So I'm gonna now explain about our calculation method. So our calculation are x plus y, which is subtracted to a. So as you can see, we need to assemble the code. So we organize at the 100 and then we load x and add y and subtract a, which as you can see over here, we place the x, y and a, and we did a coding regarding to that, and then we store z at the hot. To declare the values, we need to place the values over here. So we need to declare as x decimal point to 30, which is x, we declare as a 30, then y decimal point, we declare as a negative 20, then we need to subtract, which is we mention as a symbol, so it's a decimal point as a 5. So each are the values of the functions. So now we're gonna run it through. As you can see, we need to redo the simulation. As you can see, once we step, it will load the x, which is 30, and the MBR, the memory bus, the memory buffer register will show 001 E, which is in the hexa, and the accumulator will be shown as a exact point, which is 0013. The accumulator is function as the shows the real value of the each value before the calculations happen. So let's say if load x is equal to 30, so the XR point will be the 001e, so it will show. So once we step into another counter, it automatically will be add to the -20, which will to the y. So it will shows the exact point. The MBR will show the exact point of -20, which will show FFEC. As you can see over here, it will show the decimal point which is -20. The memory buffer register will be show the FFEC, and the accumulator will be show the 000A, which will be the answer, which is -10. So the accumulator will show in the XR point, which will be 000A. So as you can see here, it's already subtracted, so it shows the accurate value. So the instruction register will show exactly as here, and it shows the memory address register also showing as the same over here, as you can see over here, which is called 1100, 1101, 1102, 1103, 1104, and 1105 and 1106. So exactly showing as over here. So once we add the y, it will show the exact value, which is 000A. Then we move to the subtraction. We need subtraction method, so we step another again. So as you can see here, the store is the green color indicating the next step we're gonna move through, and the highlighted one, as you can see over here, it show fade away, but you can see if you focus a little bit, you can see it's highlighting the subtraction instruction. So once we subtract A, the A value will be shown in the memory address register, which is 0005, and then once we subtract with the A, we get a final answer, which is 5. So our AC also will be showing 0005, and then we need to store the answer. Once we store the answer, you can see the accumulator will be store the answer as a 0005, so it will lock the point. Then we need to halt it. Once we halt it, the halt holds the value of 7000, which is the memory of the decimal point, which will show in the XOR point. So once we halt it, we will get the accumulator of 0005, and instruction register which will stay at 7000, and a memory address register which is stored at over 1104. We can also claim it as a 1000, 101, 102, 103, and 104, 105, and 106. This is how we simulate this. So once we restart, we need to run it. Let's if it's run like automatically. So if we run it, you can see actually it's done the simulation by periodic method, which is accurately 1 by 1, but because the delay time is so short, it will move so fast till we couldn't notice it. So if we increase the delay time, we can see actually it moving 1 by 1. As you can see over here, yes, load X, then it will move to add, then it will subtract with A, then it will store, and then it will hop. That's all for me. Thank you so much.
Hello everyone, and now I will be continuing with the discussion. By using Mary, we were able to use the concept that we wanted. and assembling the language code accordingly, we were able to get load X, add Y, subtract Z, and store Z. We were also able to create a simple design that consists of memory for storing programs and data, a CPU that consists of an ALU and many registers. Meanwhile, after all, transfer the hex to binary that consists of load X, add Y, sub Z, store Z, and halt to end the program with the origin statement. Lastly, we need to state the program with symbols to define the variable and place for its volume. Okay, that's all for me.
Okay, I want to explain about the conclusion. Based on the assignment project that has been given, the thing that we can out to conclusion is we need to illustrate and simulate the basic computer concept by using the Mary software. Not only we can learn basic computer architecture, but also we can learn actually how the processor works. We successfully complete the simulate and understanding how to derive the assembly code to express the equation. Mary is a Mason architecture that is simple, consistent memory to store the program data and a CPU consisting of an ALU and several registers. Students be able to knowledge about the basic simple computer. To complete the task, we also made a few research about the basic computer concept on the internet. We complete the illustrate and simulate successfully. Okay, thank you. That's all for me.